All right, good morning, guys. Today we're going to be covering 8.9 areas of circles, sectors, and segments. Our learning target is I can find the area of circles, sectors, and segments. So let's go ahead and jump right in. First off, things that we should know before we can actually do this lesson today. We need to know the area of a circle, and we should know the area of the circle as area is equal to pi r squared. Now, of course, r is going to represent our radius. 3.14159 is pi. Of course, it's irrational, so it continues forever. And then this donation of area of a circle, that's all this means. So that's one thing that we must know in order to complete today's lesson. And the other thing is the amount of degrees in a full rotation of a circle. And of course, we know that as 360 degrees. With those two things, we should be able to complete today's lesson. So our first problem, we want to find the area of a circle whose diameter is 10. So the distance from one edge through the center to the other edge is 10 units. Now, of course, I can find the area of the circle, but first I can relate diameter to radius. I know that my radius will always be half my diameter, so therefore my radius must be 5. If my radius is 5, then I can plug that into my area formula. Area is equal to pi r squared, or area is equal to pi times 5 squared. 5 squared will give me 25, so therefore our final answer is 25 pi units squared. Of course, if they asked me to round it to the nearest tenth, I'd multiply 25 by pi, and I'd write out my final answer rounded to the nearest tenth if needed. Let's go ahead and try out another area problem. This one will be a little bit more difficult. They tell us to find the circumference of a circle whose area is 49 pi square units. So first off, if I want to find the circumference of a circle, circumference is just equal to 2 times pi times the radius. So what I need here, because 2 and pi, these are just numbers, what I need is the radius. And I can find the radius with area. So I'm going to go ahead and use my area formula in order to find my radius. I'm going to have the area of my circle, 49 pi, is equal to pi r squared. At this point, I want to go ahead and get r by itself. So the first thing I'll do is I'll divide both sides by pi. That'll leave me with 49 equals r squared. The pi's will cancel each other out. At this point, I want to get r by itself, so I need to get rid of the square. To get rid of the square, we take the square root of each side. The square root of 49 will leave us with 7. So therefore, our radius is 7. At this point, I take my radius, and I plug it back into our circumference equation, 2 pi r. That will leave us with circumference is equal to 2 times pi times 7. Well, 2 times 7, that'll just leave us with 14. So our final answer is 14 pi units. All right, now that we have area of a circle down, we're going to move to the area of a sector. So the area of a sector of a circle is just the area of a section of the circle. So a sector of a circle is defined as the region bounded by 2 radii in an arc of the circle. So it's mainly just a section of the circle's area. That's all we're going to be finding. We find the area of the circle, and then we take a fraction of that circle just to take the portion of that area. So in this case, I have sector hop, and that's how we'd see it typically. You see a shaded in area of the circle. And of course, this is the non-shaded area. We're not looking for this area that's in white. We're just looking for the blue area here. So the way that I would find hop is first off, I would need this angle O, because angle O is a central angle. So let's say I give it a random number. Say I give it 84 degrees. Well, if angle HOP is 84 degrees, then arc HP is also 84 degrees. Because if I have a central angle, it will always be equal to the arc that it is facing. So at that point, I can go ahead and use an equation in order to find the area of the section. I find the area of the whole circle using area is equal to pi r squared, and then I multiply it by a fraction of the circle. And that fraction would be 84 out of 360 degrees. So therefore, our equation for the area of a sector will be the area is equal to pi r squared times the fraction. times the arc over 360 degrees. Of course, this will be used for degrees, and this will be the most common one that you guys will be using. Now, this pi r squared, this again is just the area formula. This is the area of a circle. And then over here on the other side, the arc HP over 360, this is just the fraction of the circle. So that's how we can always determine which one we are using. We see that we have the area and we multiply it by the fraction that's given to us. Now, if we were given radians instead, if they told us that we had a certain amount of radians for the opening of the circle, then the only thing that would change is the 360 degrees would change to become 2 pi. So if I'm given radians, then be the arc divided by 2 pi times the area of a circle, pi r squared. Now again, degrees is the one that you'll see much more often. It's going to show up many more times as you guys are working through your problems. And again, we have the area of a circle and the fractional portion of the sector. So let me go ahead and get rid of that. And then, as I said, this one will be the most commonly used. So make sure that you are comfortable with the degrees one. You're going to see that much more often than the radian one. All right, let's go ahead and try out a practice problem with this. So we'd like to find the area of a sector with a radius of 12 and a 45-degree arc. So since we're dealing with the area of a sector, of course, the area of my sector is equal to my arc over 360 times pi r squared. In this case, my arc is 45 degrees, because again, it would be the same as my central angle. So I have 45 degrees over 360 degrees total times the area of my circle, pi r squared. The radius is 12, so I have pi times 12 squared. I can reduce 45 over 360 over into 1/8. And 12 squared will give me 144. So I have 1/8 times 144 pi. 1/8 times 144 pi will leave me with 18 pi units. Squared, of course, because it is an area, all of our units will be squared. So that is our final answer. Of course, if it said round to the nearest tenth, multiply it out, and then round to the nearest tenth. All right. As for our most difficult portion of today's lesson, this will be the area of a segment. The definition of an area of a segment is a region bounded by a chord of the circle and its corresponding arc. Now, you can think of it as the area of a circle that is cut by a segment. So we have a picture of it right here. I have a chord right here, my segment, AB, and I have arc AB. The area of the segment is defined as the area from the chord and its corresponding arc. So we're just going to be looking for this area in here. Now, there is a way to do this, and this is going to be a little bit more difficult of a concept, but it is still possible to do. So what we need to do in order to come up with this equation is we need to think if I wanted to find the area of the segment, what could I draw inside of the circle in order to create another inscribed shape? So the hint is inscribe a shape into the area of a sector. So if I were to draw my sector, here's the center of my circle, I'll call it O, and I draw my radii in to point A and point B. Well, what shape did that create? It created a triangle. So to find the area of a sector, the area of a segment, to find the area of a segment, I'm going to take the area of my sector and subtract the area of the triangle from it. And that will leave us with just the area of the segment. So let's go ahead and see how this works. The measure of the arc of the segment FN is 90 degrees. The radius of the circle is 10. Find the area of the segment. So they're telling me that this arc is 90 degrees. If this is 90 degrees, then my central angle is also 90. They also tell us that the radius is 10, and we want to find the area of just the segment. So again, if I subtract the triangle from the area of the sector, then I'm just left with the area of the segment, as we can see here. So At this point, we can go ahead and plug it into a new formula for us. The area of a segment is equal to the arc divided by 360 times pi r squared minus the area of a triangle. Now again, this 1/2 base times height, this area of a triangle, this can only be used with right triangles. If it's not a right triangle, we're going to use a different equation. And the other equation will be more beneficial to us because it can be used with any triangle whatsoever that you run into. But for this one, since we have a 90-degree angle, let's go ahead and plug it into what we already know from when we did area back in the day. And this will give us 90 over 360 degrees times pi times 10 squared minus 1/2 10 times 10. Again, both of these will be the same because within a circle, all radii are congruent. So again, that gives me 90 over 360, which I can reduce down to 1/4, times 100 pi minus 1/2 of 100. 1/4 times 100 pi will leave me with 25 pi. Half of 100 is 50. 25 pi minus 50 leaves us with 28.5 units squared. Again, still in area, so we're still going to be set in units squared. All right, let's try another one. But this time, let's say that our triangle is no longer a right triangle. So what do? Well, we're going to do the same type of formula, except that equation for the area of a triangle is going to change. So in this case, we already had the area of a segment is equal to the arc divided by 360 degrees times pi r squared, and then minus the area of a triangle. Now in this case, it's no longer a right triangle, so we're going to do what we did in trigonometry. We're going to use trig in order to solve for this. So if you recall, when we were using trig, we had the equation for the area of a triangle for any triangle as area is equal to 1/2, whoops, there it goes, 1/2 A times B sine of angle C. Now, if we think about it in this way, if you recall, we were looking for side angle side when we were dealing with this. And that's what we have here. We have a side, the radius, the angle, the central angle, and the side, the other radius. So we already have everything that we need to do this equation. So we can go ahead and simplify this further as the arc over 360 times pi r squared minus 1/2. We said that A and B are radii. So that'd be 1/2 times r squared times sine of our central angle. And this equation can be used with any triangle, any segment that you run into. So use this equation for any that you run into as you're working through these. So again, this is just from trigonometry, and you guys will be using this in the future too. Plugging in our information into this, let me go ahead and put up everything that should be in this slide real quick and erase all my old stuff. So again, this is just where this equation comes from, and it's showing how we're using right triangle trig in order to solve for it. So again, this is the equation that we just talked about. This is exactly where it came from. I just changed the arc to this actual problem's arc, and then I also changed it to O's center. So it'll always be the center of your circle because that will always be your central angle anyway. Plugging in our values, we get 121 over 360 times pi times 5 squared minus 1/2 5 squared times sine of 121 degrees. From here, I'm just going to go ahead and you can either enter this whole thing, parentheses and all, into your calculator for your final answer. But what I'm going to do is I'm going to split it up term by term. So I'm going to stop at the minus sign. So plugging in this first term into my calculator, we're left with 26.4. Plugging in 1/2 5 squared sine of 121 into our calculator, we get 10.7. 10.7 minus 26.4 will leave us with 15.7 units squared. All right, our final problem for the day. Given the circumference of a circle is 16 pi and an intercepted arc has a measure of 71 degrees, find the area of the segment. So they're already telling us that the intercepted arc is 71 degrees, and they're not telling us the radius, but they're giving us circumference instead. So here's our picture, and as we can see, we have our segment right over here. Now, if they give us the circumference, I can go ahead and say that our circumference is equal to 2 pi r. And our circumference is also equal to 16 pi. So I can say 16 pi equals 2 pi r. From here, I can solve for r. All I need to do is divide both sides by 2 pi. That'll leave me with r is equal to 8, as the pi's will cancel. I can go ahead and draw those into my picture. And now we can use the area of a segment. The area of the segment is equal to our arc, 71 degrees, over 360 degrees in a full circle, times pi r squared. So our radius is 8, so pi times 8 squared, minus 1/2 times radius squared once again, times 8 squared, sine of our central angle, 71 degrees. So again, 71 over 360 times pi 8 squared minus 1/2 8 squared times sine of 71 degrees. Again, you can enter this into your calculator portion by portion. 71 degrees divided by 360 pi times 8 squared will leave us with 568 pi over 45. 1/2 of 8 squared times sine of 71 will leave us with 30.26. Subtracting 30.26 from 568 pi over 45 leaves us with our final answer is about 9.4 units squared. So that is it for the difficult questions that we're going to be covering today. It doesn't get more difficult than this type of question that you just did. The last thing that I really want to make sure that you guys have both of these equations within your notes. The area of the sector, which is arc over 360 times pi r squared, and then also the area of the segment, which is just the area of the sector minus 1/2 r squared, sine of your central angle. Again, if you have these in your notes, you should be able to complete any problem that you run into for your homework. Other than that, thank you guys so much for coming in today and watching the video. Have a great rest